Welcome to qnawire.
Our question says, for the vectors given in figure 38, determine A, vector A minus vector B plus C, B, vector A plus B minus C, and C, vector C minus A minus vector B. Okay, so I wrote down what we have given based upon looking at figure 38. So we're given that the magnitude of vector A is 44, the magnitude of vector B is 26.5, and the magnitude of vector C is 31. The angle A with respect to the x-axis, the plus, going in the plus x direction, so that's starting at 0 degrees on the right side of the x-axis. Going up is 28 degrees, we're told. B, it shows that it's 56 degrees, but that's from the minus x-axis. So that's actually 180 minus 56 degrees, and that is 124 degrees, okay? And so that's theta B. And then theta C is 270 degrees. And that is because theta C, the angle of C, is along the minus y-axis, okay? So the question is, determine the following. And I wrote out what A, B, and C, as I previously stated, are. In order to do this, we're going to need to determine the, we need to determine A, which is made of A of x plus A of y, B, which is made of B of x plus B of y, and C, which is made of C of x plus C of y. So we need A of x, A of y, B of x, B of y, C of x, C of y. In order to do that, so we're going to go ahead and do that calculation here. So A of x is equal to, so this is the x component of vector A, the magnitude of A multiplied by the cosine of theta A. Cosine because it's in the x direction. So 44 times the cosine of 28. If you plug that in, that gives you 38.85. I'm going to go ahead and draw this so we can keep that separate from our solution that we're working here. AY is the magnitude of A times the cosine, or I'm sorry, not cosine, because it's y, it's times the sine of angle A. Okay? And this is 20.66. Okay? Now we need to do the same thing for B. B of x, magnitude of B, times cosine, because it's in the x, of the angle B. Okay, so magnitude of B is 26.5 times the cosine of 124 degrees. And that's going to be negative 14.82. That makes sense because B is pointing in the negative x direction. So the x component of B is negative 14.82. Okay, and now we wanted to determine the y component, B sub y. And as before, we're going to multiply the magnitude of B times the sine this time, because it's the y component, of the angle theta B. So 26.5 times cosine of 124 is going to give us 21.97. Makes sense that it's in the positive y direction because B is in the positive y direction. Okay, and lastly, we need to do this for C. So C of x is going to be the magnitude of C multiplied by the cosine of C. But theta C is 270. There's no x component of x, or of C, right? It's in the negative y direction. So just intuitively, we know it's going to be 0, plus the cosine of 270 is 0. So intuitively and mathematically, it's 0. Okay, and then C of y, well, let's just jump right to the answer because this is pretty easy with the same logic to get to, because the cosine of negative 270 is, or of 270 degrees is -1, but we know that all of C is in the y direction. It's in the negative y direction. So the the y component has to be minus the magnitude, minus 31. Okay, now using all of these, we can determine the vectors that we're asked to calculate for part A, B, and C. Ran out of room here, so we're going to go ahead and go to a new page, and we're going to start with part A. So we'll label this part A. Okay, and part A asks us to calculate A, vector A, minus vector B plus vector C. Well, you can only add like components. So we have to add the, you can only add and subtract like components. So we need to carry out these actions for the x components of A, B, and C and the y components of A, B, and C. And you're going to add those together to get your new vector. So you have A minus B plus C. When we in here, these are the x components. So you're going to carry that action out for the x components of the vectors. Okay. And then you're going to add that to this being carried out to the y components of the vectors. A minus B plus C. Okay. Well, as we already previously calculated, the on this page here, if we go back and look, we have the x, y components of all of these values. So we have 38 for AX, we have 38.85. Minus the x component of B, which we found to be minus 14.82. So this is minus 14.82. And the x component of C was 0. So we don't have to put anything there. And this is all the x component. Okay. Make sure that doesn't look like a 1. Okay. And then we add the y component, doing this to the y component. So the y component of A was 20.66. Minus the B component, the y component of B, which was 21.97. Plus the y component of C, which was minus 31, plus the negative's just minus, so we can write that as minus 31. Okay? And that's y. Okay? And if you carry this out, if you go ahead and do those calculations, you will find that this comes out to be 53.7. I'm going to write this in the I hat direction, which is the x direction. It's another notation for x direction. And this is, excuse me, it's not plus, it's minus 32.3. And this is in the y hat direction, or also the j hat direction. Okay. And the reason we report this to 3 significant figures is our values in the beginning were reported with an accuracy of 3 significant figures. If you go back here, all these values in the given section are 3 significant figures. So that's the most accurate we can report to. Okay. Now we're going to do B. Okay. B was this time A plus B minus C. Okay. And as before, we're going to do this for A plus B minus C. Doesn't look like a very good B. That's better. And this is for the X plus A plus B minus C for the y. Okay. And if you look above, we have the values for the x component of a, b, and c and the y component of a, b, and c written there. But now we're going to change whether or not they're added or subtracted. So you have 38.85. And this is going to be plus minus 14.82. So a plus and minus is just minus 14.82. Okay. And this is in the x direction. And this is plus. And also note again, c of x is 0, so there's no c of x. And this is plus 20.66. And then plus, this time, 21.97. Right? And then this time it's minus 31. Well, minus a minus is a plus, so this is plus 31. And that's y. Okay? And then, if you carry this out, this is equal to 24. Again, this is the i hat direction. And then plus, I'm going to do that, plus 73.6. J hat direction. Box that in as your solution. Okay. And lastly, we need to do part C. So rewrite part C, where part C was C minus A minus B. These are all vectors. Okay. Well, that's C minus A minus B x direction plus C minus A minus B y direction. Okay. Well, C for Cx is 0. This A is 38.85, so that's minus 38. Let's see, a little more recognizable. There we go. 38.85. Minus B, which B was minus 14.82. So minus a minus is a plus 14.82. Okay. And this is the x direction. Plus, we're going to do this for the y direction now. So C is minus 31. Minus A. A in the y direction was 20.66, so it's minus 20.66. Okay. And then minus B. B in the y direction was 21.97, so this is going to be minus 21.97. Okay. That's the y direction. Okay, if you go ahead and carry this out, you will see that it's minus 24. And this is the I hat direction. Plus, or I'm sorry, minus 73.6 this time. And that is in the j hat direction. Box that in as our solution, part C.